Hey guys, Mrs. Stans here. So feels like it's been a long time since I had to make you a video. So here's the objective. You can hit pause at any time and get this down. I'm also asking you to do the do now without me, right? And then check your answers according to mine. So by this time, you really should know how to graph using the slope and y-intercept. And if you do, you'll see that today's lesson is actually super simple. So the first equation, the slope is 2, which can be written as 2 over 1, and the y-intercept is negative 3. So remember, we start here on the y-axis. So I'll put a point at negative 3 on the y-axis. It's the point 0, negative 3. And if the slope is 2 over 1, we're going to go up 2 and to the right 1. If you have any friends in my Math 8R class, you could also ask them for help on this. This was their do now also for lesson 1 in their Systems of Equations workbook. Remember, in order to get full credit, your lines have to be extended to the edges of the graph. They do need to have arrows, and you do need to label it. The second equation, the slope is negative 3 over 2. The y-intercept is 4. That's really the point 0, 4, because it's on the y-axis. And if the slope is negative, it means to go down 3 and to the right 2. Again, extend to the edges of the graph paper. It really is difficult for me to draw a straight line on this pad that I use. Make sure you label the line. And then underneath the graph here, it says state the point where the two lines intersect. So the point where they intersect is this point, and that's the point 2, 1. Remember, it's called an ordered pair. Order matters. That order is important. 2, 1. And there we go. We're going to take some additional notes. That point of intersection is called the solution to the system. A solution, actually, first let's talk about a system. A system of equations means that we have more than one equation. And the solution to the system is always the points that they have in common. And in this case, these two lines have one point in common, and that one point is 2, 1. Now we can check and make sure this is the solution to the system by substituting in the point 2, 1 into the first equation, and by substituting the point 2, 1 into the second equation. So on the next page is where they have us do the checks. This just tells you what I told you about a system. And that the solution is the point of intersection. So we're going to be checking the point 2, 1 in the first equation. This is your x value, and that's your y value. So 1 equals 2 times 2 minus 3. Does 1 equal 4 minus 3? It sure does. 1 equals 1. So the point 2, 1 is definitely on this first line. Remember, to be a solution to the system, it has to be on both lines. It has to be points that both lines share. So that's why we have to do a second check, because there's a second equation that we're hoping that this point is on. So again, we're going to substitute the values into the correct spots. And you can see that this one checks as well. Let's practice some more. That's it. I actually just taught you everything, by the way. You already know how to graph. You already know how to do checks. The only new piece of information is knowing that the solution to a system is the point or points that the lines share. I really do want to go over example 1 with you. For some reason, some people really have a hard time graphing horizontal and vertical lines. So this first line is actually a horizontal line, and the second one is a vertical line. Just to remind ourselves of what we did in a do now even, both do now equations were in the form of y equals mx plus b. If an equation is in the form of y equals mx plus b, or can be manipulated into the form y equals mx plus b, we know it's a diagonal line. When an equation only has a y in it, and it tells you that y equals some constant number, that's when it's a horizontal line. And when an equation only has an x in it, where x equals some constant number, that's a vertical line. Just as a reminder, vertical lines are not functions, right? Because there's an input that has multiple outputs. This is a function. This is a function. And this is not a function. Just some review for you. So let's go back to example 1 and graph the horizontal line of y equals -2. Here's where y is -2. Y is -2 on every single point on this line that I just drew. And then we'll graph x equals 3. X equals 3 at every single point on this vertical line that I just drew. And remember, the solution to a system is the point or points that they have in common. This has one point in common. The solution to the system is at 3, -2. We'd be able to do a check for it, but it's like the easiest check in the world. If I want to check the point 3, -2 in the first equation that says y equals -2, all I have to do is replace this y with the appropriate number. I'd have to replace it with a -2, so it automatically checks. And then if I want to check the point 3, -2 in the second equation, I just have to replace this x with the appropriate number, which happens to be 3, and it automatically checks. Let's do example 2. I'm coming over here to the side because the first equation in example 2 is definitely a diagonal line. There's an x and a y in it, but y is not by itself. So we have to solve this literal equation by subtracting x from both sides, and I get that y equals -x plus 2. So that means that my slope is -1 and my y-intercept is 2. It's a y-intercept, remember, so start on the y-axis. And if the slope is -1, you could put a 1 underneath it, so it means go down 1, right 1. You could always use the table of values feature in your graphing calculator, but what a waste of time that is when we can easily graph using the slope and y-intercept. My Math 8R students don't even have graphing calculators, so they do just graph using the slope and y-intercept. Make sure you label the line. I like labeling it the original equation. This second equation, it's already in y equals mx plus b form. The slope is -1 and the y-intercept is -2. So I have to start at -2 on the y-axis, and I have to go down 1, right 1. And what you should recognize is that these lines are parallel. You should have known that already even without graphing, because we learned in our last unit that parallel lines have the same slope. So notice that the slope of the first equation is -1, and the slope of the second equation is also -1. So these lines are parallel. Well, the solution to a system is the point or points that they have in common. So how many points are in common in these two equations? Right, no points are in common. No points in common. So if someone asks you what the solution is, you'd say that there's no solution. There are no points in common. Remember, parallel lines have the same slope. If you have forgotten that, give yourself a note. I'm going to say have equal slopes. So as soon as you see that they have the same slope, even without graphing, I knew that there was no solution. Example 3, we have to get it in the right form. So I'll write this 2y plus 4x equals 8. I like separating my equations. I wish I had more room when I did number 2, because I like really keeping track of everything. Like the second equation, I can easily say that the slope is -2 and the y-intercept is 4. And just by writing that down, that's work. On the first equation, I couldn't write it down yet because it's not in the right form. So I will subtract 4x from both sides. I'll divide both sides by 2. And the slope is -2, and the y-intercept is 4. Are you noticing something interesting? If I graph the first line, I'll start at 4, and I'll go down 2 and to the right 1. I like to extend as far as I possibly can. Remember, you could always pause the video anytime you need to. I'm labeling this with the original equation of the first one given to me. Now, if I graph the second one, I'm changing color so that things stand out. I start at 4 and I go down to right 1. So what do you notice? Yeah, it is. They're like the same line, right? Instead of calling it the same line, I just like to say that they're lines that are on top of each other. They really were two different equations. These two equations just look like the same line. So how many points do they share? Right, they share every single point. So what would you say the solution is? Well, you could say it's 0, 4, and it's 1, 2, and it's 2, 0, and it's 3, -2, and oh my gosh, so many. There's arrows at the ends of the lines even. Isn't there an infinite number of solutions? Every single point on one line is on the other line. They share all their points. So what we say about this is that there's an infinite number of solutions. I can't name them all. So when we solve a system of equations, our goal is to find the point or points that they have in common. If there is one point in common, you should do a check to make sure you graphed your lines properly. If there aren't any points in common because the lines are parallel, there's nothing to check. A check is so that you can see if the point you chose is correct. I didn't choose any point. I have nothing to check. There is no solution. I'm not going to make you do a check for an infinite number of solutions, but you know what? You can verify that there are an infinite number of solutions. Check a few of them, right? More than one point should work. If you really graph this correctly, one of the points will work, another point will work, another point will work. So if you want to make sure you did your graph correctly, you can check like 2 points. And if both points work, you can say, oh yeah, I guess there's an infinite number of solutions. Can you check them all? Absolutely not. There's an infinite number. The answers are never ending. So if you tried to check them all, you'd be checking till the day you died and still never be done. And that really is the lesson. So we just have a summary here. When you graph two linear equations on the same set of axes, how many solutions can there be? Well, there can be one solution. And let's draw a picture of what it looks like. Right there. There can be no solution. And let's draw a picture of what that looks like. And then there can be an infinite number of solutions. And I'm going to use two colors to draw this picture because I want to be able to see that the two lines really are one on top of each other. And there we go. So these are just practice for yourself, and then your homework starts here. I will require you to show me that you took the notes that we took together. This is optional. So if you don't have that filled in when you turn it in, I'm all right. And then, of course, it's mandatory to do your homework. So that's it. If you have any questions, of course, send them my way, and I'll see you soon.